Here we're moving up to using de Moivre's root theorem to find cube roots of a complex number. Now the complex number in this case doesn't look so complex, right? It's just -8. But that is a number which has both a real, well, it doesn't have an imaginary part. It can be written in the form a plus bi, where b is 0. So you can kind of call it a complex number, but that's semantics. Anyway, let's move on and actually find the 3 cube roots of -8. And you might be thinking, I already know how to do this. It's -2. Well, there's 2 more cube roots. Maybe up until now, you've never realized that -8 has 3 cube roots, not just 1. But there are 3, and we're going to find the other 2 not obvious ones. So our first task is to write z in polar coordinates. Okay, I need these things in polar coordinates. I need to know angles and modulus. So we can go through this. We've done this many times, but I think what I'm going to do here is just write the formula and assume that you have seen this a dozen times before, so I'm not going to go through the details. Okay, there's your formula for the modulus, and you will find that for this one, it is 8. And the formula for the angle, which we have also been through a ton of times, is the inverse tangent of the imaginary part over the real part. So you can plug those in, and you will find that theta equals pi. I mean, you might be a little confused about whether it's 0 or pi, but you can work through it. It's pi, using these rectangular coordinates to give you the hint. So what we get here, this is just the preliminary stuff. We got that out of the way now. Here is our polar form. And we're about to get into the good stuff now. Now that we know polar form, we can really get cooking. And by the way, you could have just looked at the graph and figured this out too, right? There's my modulus of 8. There's my angle of pi. So, you know, shortcuts. Now let's do de Moivre's theorem. And I'm going to say n equals 3. So there's a 3. There's a 3. Here's a little 3 over here, teeny 3. And first thing I want to do is, what is the cube root of 8? That's this part right here. Let's get that out of the way. That's nice and easy. Cube root of 8 is just 2. Okay? And now each one of these is going to come in the following form. You know what? I'm gonna get smart for a change. I'm gonna just write this once and then copy paste. 2 times cosine of some angle, which we'll figure out, plus I times sine of some angle. There we go. And now that is going to be the same for each of these. Can we copy? Where's my paste button? Duplicate? Monkeys. Okay, never mind. I'm not going to be smart. So, let's find that angle. Well, when you're taking the cube root, according to de Moivre's theorem, what we're doing is doing theta divided by 3. So what is theta? That's pi. Okay, theta divided by 3 is just pi divided by 3, meaning that's our first root at W0. And we can plot that on the graph by saying, oh, here's pi over 3, and we're going to go out to 2. Okay, so there's W0. And now for each of these next roots, I'm going to add a certain angle. Well, I didn't need to erase that. It's still 3 right here. I'm going to add 2 pi k over 3, where k is 1 for W1 or 2 for W2. But each time I find the next root in line, I'm just adding 2 pi over 3. So what's 1 pi over 3 plus 2 pi over 3? You got it, pi. So this next one will have an angle of pi. You probably wondered when we were going to hit this again, because you knew -2 was a cube root of -8. So there's W1. And W2 is just going to be another 2 pi over 3. So what do we get there? Well, you can do this. It might be easier visually, right? You might have an easier time just adding these things up on the graph. I know I got to that point. And it looks like that is 5 pi over 3. Okay, so there are my 3 cube roots in polar form. And doesn't this look nice? I just get a big kick out of these graphs.